Right now, underneath one of the busiest ports on the entire planet, there's a fault line that scientists spent decades believing was extinct, and new research says they were wrong. The Wilmington Fault runs for 12.5 miles directly beneath the Port of Los Angeles and the Port of Long Beach, the two busiest container ports in the entire United States, handling close to 40% of everything that arrives into this country by sea. For years, geologists looked at this fault and saw no clear surface rupture, no obvious recent movement, and concluded it had gone quiet millions of years ago. A new three-dimensional analysis, built from decades of oil industry seismic data, and published by researchers including a structural geologist from Harvard, tells a completely different story, one where this fault is very much alive, capable of producing an earthquake of magnitude 6.3 or greater, sitting directly beneath billions of dollars of shipping infrastructure that the entire country depends on. And this is not the only hidden threat sitting beneath the city. Today, we are going to walk through exactly what scientists found under Los Angeles, why a fault can hide from an entire century of research, and what this actually means for the millions of people living directly above it. No exaggeration, no doomsday guessing, just the geology, the data, and the real stakes. Drop a comment right now. Have you ever felt a small earthquake and had no idea which fault actually caused it? Tell me where you were and what it felt like. So many of you live across Southern California, and I always want to hear those stories. If you want to know the moment anything changes with any of these fault systems, subscribe right now. It costs nothing. And a thumbs up tells the algorithm to put this in front of people who actually need to see it. Let us get into it. Most people picture California earthquakes as one single line on a map, the San Andreas Fault, cutting the state in two. But Los Angeles does not sit on top of the San Andreas. The city sits inside a basin, and that basin is laced with a completely different category of fault that almost nobody outside seismology talks about, the blind thrust fault. A normal fault, like the San Andreas, is a strike-slip fault, meaning two blocks of crust grind past each other sideways, and you can often see the fault trace right there on the surface. A blind thrust fault is different and far harder to find. It is a fracture where one block of crust is being shoved up and over another at an angle, folding the ground above it like a rug being pushed from one end, but the fault plane itself never breaks the surface. There is no visible crack to map, no obvious scarp running through a neighborhood. The only evidence is a gentle, almost invisible fold in the rock layers deep underground, and you can only see that fold if you have the right data and know exactly what you are looking for. This is precisely why the Northridge earthquake in 1994 caught the region so off guard. It was magnitude 6.7, it killed more than 60 people, injured thousands, and caused over $20 billion in damage, and it came from a blind thrust fault that nobody had mapped in advance. In the seconds before dawn on January 17th, ground acceleration near the epicenter in Reseda was measured among the highest ever recorded in an urban earthquake in North America, strong enough to fling parked cars and snap freeway overpasses that engineers had assumed were built to survive far worse. Entire sections of the Santa Monica Freeway and the Antelope Valley Freeway interchange collapsed. Apartment buildings with parking structures on the ground floor, a design that was common across the region at the time, pancaked directly onto the units above them while people were still asleep inside. That earthquake became the wake-up call that sent structural geologists back underground with a new question. If one blind thrust fault was sitting there undetected beneath a major American city, how many others are down there too? That search eventually led researchers to the Puente Hills Thrust, a fault system stretching roughly 40 to 50 kilometers from northern Orange County, directly beneath downtown Los Angeles, all the way to near Beverly Hills. Scientists studying borehole data found evidence of at least 4 major earthquakes on this fault over the past 11,000 years, each one in the range of magnitude 7.2 to 7.5, and confirmed that a smaller segment of this same system produced the 1987 Whittier Narrows earthquake. A fault capable of a 7.5 sitting directly under the core of downtown Los Angeles remained essentially invisible until seismic reflection data and relocated earthquake records finally exposed its outline. And now the Wilmington Fault has joined that list. The reason scientists originally wrote this fault off is almost more unsettling than the discovery itself. Structural geologist John Shaw of Harvard, who led the new analysis, explained that hints of the underlying fold do still show up in shallow rock layers near the southern tip of the fault. But the pattern of that folding had led earlier researchers to conclude the structure had stopped moving long ago. Using a three-dimensional model built from decades of subsurface data, Shaw's team found the opposite, evidence suggesting the fault has actually been active far more recently than anyone assumed, and is likely still capable of rupturing today. It moves slowly. Researchers estimate roughly once every 3,200 to 4,700 years, which is exactly the kind of timescale that makes a fault easy to dismiss and easy to forget, right up until the day it moves again. The Wilmington Fault is not an isolated curiosity either. It sits inside a broader system of blind thrust faults folding beneath the entire Los Angeles basin, structures that geologist Chris Goldfinger has described as the region's evil twin, hiding in the subsurface while all the public attention stays fixed on the strike-slip faults everyone can see and map from the surface. And that raises the exact question researchers say keeps them up at night. If the Wilmington Fault stayed hidden this long, sitting directly beneath one of the busiest ports on Earth, what else is still down there that nobody has found? It is also worth understanding exactly what sits directly on top of this fault, because it is not an empty stretch of coastline. The combined Port of Los Angeles and Port of Long Beach complex processes container traffic worth hundreds of billions of dollars every year, and beneath the terminals themselves run pipelines carrying crude oil and refined fuel, high-voltage transmission corridors feeding power into the entire Los Angeles basin, and rail lines that move goods inland to the rest of the country the moment a ship is unloaded. Study author John Shaw was careful to frame the discovery constructively rather than as a reason for alarm, noting that identifying an active fault gives engineers and port authorities the chance to fold that risk directly into how cranes, storage tanks, and terminal foundations are designed and retrofitted going forward, rather than discovering the hard way during an actual rupture. This is not happening in isolation from everything else Southern California's fault network is doing right now either. A separate study published this year modeled 1,000 years of earthquake history along the San Andreas and San Jacinto fault systems, the two structures that together accommodate roughly 90% of the tectonic motion between the Pacific and North American plates in this region. Researchers found that stress on multiple segments of these faults has now reached or exceeded the highest levels recorded in that entire 1,000-year window, concentrated specifically around a junction called Cajon Pass, just northeast of Los Angeles, where the two fault systems meet closely enough that a rupture on one could potentially jump onto the other, turning a single fault earthquake into a much larger multi-fault event. The lead researcher on that study was careful to stress that elevated stress does not equal a prediction, and one of her collaborators, a seismologist at the University of Southern California, put it plainly, the crust in this region is critically stressed and ready to rupture in a large event, but whether that happens tomorrow or in 30 years is simply not something current science can pin down. Researchers reconstructed that 1,000-year stress history using radiocarbon, dated sediment layers, tree ring records, and historical written accounts of past ruptures, then fed all of it into a physics-based computer model to calculate how much accumulated energy is currently locked into the fault system, a method the study's authors say can now be applied to other complex fault junctions anywhere in the world, not just Southern California. What all of this adds up to is not a single ticking clock, it is an entire layered system, visible faults. Like the San Andreas building stress for over 160 years since the last major rupture, and invisible blind thrust faults folding directly beneath downtown neighborhoods, ports, and infrastructure, some of them only being confirmed as active in just the last few years. And here's the detail that should reframe how everyone thinks about California earthquake risk: blind thrust. Earthquakes are disproportionately destructive for their size, specifically because of how the energy travels. Their seismic waves are highly directional, focused rather than spread evenly outward, and when that energy hits the soft sedimentary basin soil that much of the Los Angeles metropolitan area sits on, the shaking can be amplified tenfold or more compared to the same magnitude event on solid bedrock. That is precisely why a magnitude 6.7 event like Northridge produced the kind of destruction usually associated with a far larger earthquake. And it is exactly why a Wilmington Fault rupture at magnitude 6.3, directly beneath critical port infrastructure, sitting on soft basin soil, is not a number to dismiss just because it looks smaller than the 7.5 potential of the San Andreas. Despite all of this, seismologists are consistent on one point that deserves equal airtime to the warnings. California's building codes, especially anything constructed or retrofitted after Northridge, exposed the weaknesses in the 1994 building stock, are specifically engineered around exactly this kind of shaking. Critical infrastructure like ports, pipelines, and major bridges undergo seismic risk assessments precisely because faults like Wilmington and Puente Hills are now on the map. Discovering a hidden fault is not the same as discovering a new danger appearing out of nowhere. It is scientists finally being able to prepare for a risk that was always physically there, just unmeasured. Earthquake scientist Wendy Bohan put the entire situation in the simplest terms possible. In Los Angeles, it has never really been a question of if, only when. And the healthiest response is not panic, it is preparation. Know your evacuation routes, know where your gas shutoff valve is, secure heavy furniture and water heaters to the wall, keep a real emergency kit with water, food, and medication for at least 72 hours, and have a family communication plan for when cell networks get overloaded, because that is exactly what happened in Northridge, and it will happen again in the next major event. If you rent rather than own, ask specifically whether your building has undergone a soft story retrofit, since older apartment buildings with open parking underneath the living units were exactly the design that failed catastrophically in 1994. And many cities across the basin have since passed mandatory retrofit ordinances precisely because of what that earthquake exposed. If you drive for work anywhere near the ports, or if your job depends on goods moving through them, it is worth knowing that terminal operators are required to maintain their own seismic response plans, but your own household plan should never depend on assuming someone else's infrastructure held. If you live or work anywhere near the ports of Los Angeles or Long Beach, or anywhere across the wider basin from Beverly Hills through downtown to Orange County, these are not abstract structures on a research paper. They are folds in the rock running directly beneath your daily routine, and the single best thing you can do with that knowledge is not fear, it is readiness. Final thought. The ground beneath Los Angeles has never been the simple single line most people picture when they hear the words San Andreas Fault. It is a stacked, folded, deeply layered system, with faults that broke the surface millions of years ago sitting alongside faults that never break the surface at all, hiding directly beneath the busiest port complex in the country until the data finally caught up to what the rock had been doing the entire time. Discovering the Wilmington Fault is active does not change the geology of Los Angeles. The fault was always there, always moving on its own slow, patient timescale. What changed is our ability to see it, and that visibility is exactly what allows engineers, port operators, and city planners to build for a risk that used to be invisible on paper, but was never invisible underground. We will keep tracking every new study, every fault confirmed active, and every update out of the Southern California Earthquake Center as it happens. Subscribe so you do not miss it, and leave that comment below. Have you ever wondered which fault is actually sitting beneath your own neighborhood? Because understanding what is under our feet is how an entire region stays one step ahead of the ground it is built on. Let us get this one to 5,000 likes. See you in the next one.